Let's talk about variables in this lecture. So variables have two things. Each variable has a type, and this is what we call a data type. And the other one is name, right? So variable can have a name as well, data type name. So variables are named memory locations. So once properly declared, right, even assigned with a value through initialization, the variable consumes the memory, okay? This could be an integer variable, could be a character variable or a string variable, right? Or it could be float double variables or user-defined struct or class in C++. And it depends on what type they're associated with. So basically the type determines the variable that the size of it, and even the location of it depends on how you declare it, either on the stack or on the heap. So what I'm doing here is, this is a memory cloud, okay? So this memory cloud is an abstract cloud, right? I just drew this. Suppose this is the total memory space you have on your computer chip. When you declare a variable, let's say you have this integer, I, right? Somewhere equals 4, right? This very expression right here contains a couple things. One is, let me use a different color. So you have integer, right? I. So what this I is what we call a variable. In general, this variable has two things, right? One is type, right? And the second part is the name, right? Or identifier. So this variable type integer, and this one has a value of 4. Okay, so this equal sign is what we call assignment. Okay, so we're not going to talk about assignments here because assignments is actually part of the initialization declarations. You have to have something declared of certain type and then initialize or assign a value to it. So that said, let's talk about variable, and we talked about naming convention and whatnot. Right now, let's just give a couple of examples. So what we see here is various different types of variables that we have in C. So we have a char, right? This is a character. We also have an integer. We also have a long, right? And float, doubles, and whatnot. And notice that every single one of these, this is what we call declaration. You're declaring, right? A variable, right? Identifier, you can have it as a name. So a variable's name or a variable's identifier, they all have a type associated with it, and this is how you declare. Notice that the declaration itself is a statement which ends with a semicolon. So you have to have a semicolon in order for this entire line of code, right? Char code, integer I, long, whatever, to be registered in your memory. And notice that there's no value currently assigned, right, to these things. So this is another thing about variable, and that is if you don't assign a value to these variables, technically they can have any value associated with it within the constraint of your data type. So let's say if data type is 4 bytes, yeah, there's going to be ones and zeros and whatnot, totaling 4 bytes somewhere for this integer if you do not assign a value to it. Okay, so this is one caveat you need to understand. So leaving a variable like this unassigned with a value is pretty dangerous. Okay, let's move on to the next one up. So this is another table that shows you various different variable types and their names associated with it. So there's a Boolean, B-O-O-L. In some language, you would write them as Boolean, such as in Java, but in C and C++, it's B-O-O-L. Okay, just remember that. Integer, char, float, double, float, right? So these are various different examples of variable declarations and definitions. Actually, there is no definitions. Definition is what we call defined, right? With a value associated with it. So this is just a declaration. Declaration, you're declaring a Boolean, right, called fact. You're declaring a short called max items. You're declaring a long called long, right? Long, actually, this is a long, called national underscore debt. You're declaring a variable called flow, pay rate, so on and so forth, right? So this basically means that whenever you are, means that whenever you're declaring something out of this memory map, right? Let's say this Boolean fact, right? This Boolean occupies this space right here, and this space, right, is 1 byte, okay, in memory space. And this flow right here, we talked about this, right? Flow could be here, and this one is 4 bytes, right? So you can see, depends on, you know, when and how you declare these, they can occupy various different memory location. And of course, this is all on the stack. Let's just assume this is a stack memory, okay? So we talked about a different type of memory later on. There's another type of memory called heap. So this is not how we allocate stuff dynamically on a memory footprint. This is all decoration on a stack. And as such, everything is sitting inside this cloud, you know, occupying certain areas. So like this integer is 4 bytes. So there are actually 2 integers being declared in this case. One of them is called A, and the other one is called B. Okay. All right. So let's clear this part and then move on with the next slides. All right, so the next one up is called variable initialization. So now, in addition to declaring these variables, like we did before, right, we also have this equal sign. So if you do, this is what we call declaration. This part is called declaration, okay? Now, this part is what we call assignment. When you have assignment, you have this thing called equal sign, right? So if you have decorations on an assignment all at in the same line of code before this semicolon, this is what we call initialization. So initialization is declaration and assignment combined, okay, in one shot, in one line. And this is declaration as well, like flow pay rate equals, right? So you're doing declaration, right? And then equal sign, assigning the value. So what happens is, physically what happens is this: you have this memory cloud, and your flow execution comes down to the flow pay rate, and it says, oh, there's a flow. This flow is of either 4 or 8 bytes, right? Somewhere, let's just say this is 8 bytes. Well, this is actually 4 bytes because flow is 4. We already did that. You do a size out flow, you see it. This 4 byte occupies this memory space right here, let's just say. And this memory space has a memory stick, right, on the ground. It's called pay rate, right? So what is pay rate? Pay rate is the identifier, right? Or what we call variable name, right? So whatever that is. And this pay rate occupies 4 bytes memory space. And now at this point, you have this equal sign, which means at that very moment, as soon as this memory space is declared or set aside for pay rate variable name, immediately the program assigned, right, a value of 14.25, right, to this memory space. So that is the entire memory space contains a value called 14.25. So this is the effect of variable initialization. First, you grab hold of a memory slot, right? Available memory slot. And this is all done by your computer, by the way. You're not doing this, assuming your computer has sufficient stack memory. The first thing is grab hold of this space, and 2 is to assign a value to it. So this is what we call this is the effect of initialization. Just remember, initialization, 2-step process, actually 2 things combined into one. One of them is declaration, and the other one is called assignment. This is what we call initialization, okay? As you can see here graphically, this is a stack memory, right? This memory space is represented in this green box. As soon as, let's say this national debt is declared, the value of this value goes right into it, right? So you can see this space now has a value, okay? So this is how we declare and assign value in a variable initialization. Let's move on to the next slide, which I believe is a call out. When a variable is defined, it is not initialized. So we must initialize a variable requiring prescribed data when the function starts. So the effect of, let's say, you're doing char, right? Char C, okay? Let's say this is what we call declaration, okay? Declaration. This declaration doesn't have any assignments associated with it. So there's no initialization at all. So what happens is there is this spot right here. This is C, okay? This one has a name C. And this is 1 byte, right? The problem with this is C can have anything in it. So if you don't initialize this C with a value or assign a value to it, this C could be A, it could be 0, or it could be some garbage in. This is the effect of not initializing a variable with anything, or not assign a value inside this variable. So it could be dangerous. Next time you can use C to perform something, and not initialize something would simply cause your program to behave erratically. So you got to be careful about those. Let's move on to the next one. This is a print sum of 3 numbers. So you can see here, let's just examine, right, what we have here. First of all, what we call local declaration. So there's a couple of declarations here, A, B, C, and sum. So there's nothing extraordinary about that. And later on, we try to write up this is what we call expression. This entire expression has 3, right, variables, and these are what we call operand, and plus sign is what we call operators. So you have what's called an expression, okay? This expression is being evaluated, right? Later on, we're going to talk about L value, right, and an R value. So in this case, this is a R value on this side expression. And so that said expression right here, this expression will be evaluated to a number, right? Since we're talking about A, B, C being an integer, and the summation of A, B, and C evaluates into a value that gets assigned right into this sum, SUM here, and then you can print out the whole thing here. And we talked about printf before, and so this entire thing gets the information through scanf from the user, and this is from the keyboard, your keyboard. So you can enter, let's say 1 as an A, B as C, C, right, C, so on and so forth. Let's double check on things, because I think ABCs are what we call strings. No, not string, I'm sorry. So these are integers, yes. So let's move on to the next one. And this one says A, B, and C, you're adding it. And because this printf expects this to be an address of, right? This has to take a pointer. So we use ampersand. So again, there's a lot of concepts associated with it. This is address, okay, of. So this ampersand stands for address of. So this is saying address of C, address of B, address of A. So now you're shipping it into a scanf. By way of scanf, this takes a value that you have from the console and absorb that number into it. Now you're adding all these 3 numbers up that you just enter to give you a sum, and then you're printing this sum out. Okay, so this is format specifier, right? This format specifier says %d. This means digits. So you're printing a digits out with 2 \n. This is 2 returns on a console, and the effect of this entire program gives you this. Okay, all right. So this completes our overview of a variable.